Our sun, a blazing ball of plasma, the anchor of our solar system, the giver of life. It's easy to forget, basking in its warmth, that this celestial body is a force of nature capable of incredible power. We often think of the sun as a constant, a source of unchanging light and heat. But the sun is far from static. It's a dynamic, ever-changing entity, capable of unleashing bursts of energy that dwarf anything we can create on Earth. These outbursts, known as solar flares and coronal mass ejections or CMEs, can have significant impacts on our planet, particularly in our increasingly technology-dependent world. While both solar flares and CMEs are dramatic events that release vast amounts of energy, they are fundamentally different. Solar flares are intense bursts of radiation, primarily X-rays and ultraviolet light, that travel at the speed of light. When these high-energy photons reach Earth, they interact with our atmosphere, disrupting radio communications, and sometimes even posing a radiation risk to astronauts in high-altitude flights. CMEs, on the other hand, are a different beast altogether. Imagine 1 billion tons of superheated plasma, a fiery cloud of charged particles being ejected from the sun's corona, the outermost part of its atmosphere, at millions of miles per hour. This, my friends, is a coronal mass ejection, and unlike the fleeting flash of a solar flare, a CME is a more sustained event, with the potential to trigger significant disruptions here on Earth, especially if it collides with our planet's magnetic field. Imagine a pot of boiling water. As the water heats up, bubbles rise to the surface and burst, releasing steam. Now imagine that same process, but on a scale that dwarfs our planet. That's what's happening on the sun's surface. The sun's corona, a chaotic and superheated region, is threaded with magnetic field lines. These lines, like giant rubber bands, can become twisted and tangled, storing immense amounts of energy. When these magnetic fields become too strained, they snap and realign in a process called magnetic reconnection. This sudden release of energy propels massive amounts of plasma outward, forming a CME. It's like the sun is having a cosmic temper tantrum, flinging out fiery projectiles into the vastness of space. But here's the thing, not all CMEs are created equal. Some are relatively weak, dissipating quickly in the vastness of space. Others, however, are aimed directly at Earth, and those are the ones that have us space weather forecasters glued to our monitors. These Earth-directed CMEs can create quite a stir when they arrive at our doorstep, disrupting our technological infrastructure and reminding us that we are, in many ways, at the mercy of our nearest star. A CME's journey from the sun to Earth is a tale of speed and fury. Once ejected, these billion-ton clouds of plasma hurtle through space at speeds that can reach millions of miles per hour. The trip isn't a quick one though. Depending on their speed and trajectory, CMEs can take anywhere from a few hours to several days to reach our planet. During their journey, CMEs interact with the solar wind, a constant stream of charged particles flowing from the sun. This interaction can either accelerate or decelerate a CME, making it difficult to predict their exact arrival time. Think of it like trying to predict the arrival of a leaf floating down a turbulent river. There are many factors at play. As a CME approaches Earth, it encounters our planet's first line of defense, the magnetosphere. This invisible shield, generated by Earth's magnetic field, deflects most of the solar wind, protecting us from its harmful radiation. However, a powerful CME can compress the magnetosphere, triggering a geomagnetic storm. This, my friends, is when things get really interesting. Before we delve into the potential impacts of a CME on our modern world, let's take a trip back in time to 1859, to an event that still sends shivers down the spines of space weather scientists today, the Carrington Event. In September of that year, astronomer Richard Carrington witnessed the most intense geomagnetic storm ever recorded. Telegraph systems around the world went haywire, with some operators reporting sparks flying from their equipment, even setting telegraph paper on fire. Auroras, typically only visible near the poles, were seen as far south as the Caribbean and Hawaii, painting the night sky with their ethereal glow. The Carrington Event was a stark reminder of the sun's power and the vulnerability of our technology, even in the 19th century. Imagine what would happen if such an event were to occur today. Our world, far more reliant on technology than ever before, would face unprecedented challenges. From widespread power outages to disruptions in communication and navigation systems, the consequences could be devastating. Section 5, our electric world at risk, the delicate dance of power grids and CMEs. Our modern world runs on electricity. From the lights in our homes to the internet that connects us, our lives are intricately intertwined with this invisible force. But, this reliance on electricity also makes us incredibly vulnerable to the whims of space weather, particularly CMEs. When a CME slams into Earth's magnetosphere, it generates powerful electric currents that can flow through the ground. These geomagnetically induced currents, or GICs, can wreak havoc on power grids, which are not designed to handle such surges. Transformers, the workhorses of our electrical infrastructure, are particularly susceptible to damage from GICs. A major GIC event could lead to widespread blackouts, potentially affecting millions of people. The economic impacts alone would be staggering, with businesses and essential services grinding to a halt. Remember, we are talking about a cascade of failures, a domino effect that could ripple through our interconnected world. Section 6. A sky filled with ghosts. Satellites in the line of fire. Our reliance on technology extends far beyond Earth's surface. Thousands of satellites orbit our planet, providing essential services like communication, navigation, and Earth observation. These technological marvels, however, are also vulnerable to the wrath of CMEs. The increased radiation and charged particles from a CME can damage sensitive electronics on satellites, disrupting their functionality, or even rendering them inoperable. Imagine losing GPS navigation, satellite TV, or even worse, communication with critical infrastructure like power grids and emergency services. Moreover, the increased drag on satellites caused by the heating of the Earth's upper atmosphere during a geomagnetic storm can alter their orbits, potentially leading to collisions. A cascade of colliding satellites would create a debris field in space, further jeopardizing future space missions and our reliance on space-based technology. Section 7. Beyond the comfort zone, radiation risks and the invisible threat. While the visible effects of CMEs on power grids and satellites are concerning enough, there's another, more insidious threat: radiation. CMEs are accompanied by a surge in high-energy particles, primarily protons, that can penetrate spacecraft and even reach Earth's surface. Astronauts on spacewalks or in spacecraft with limited shielding would be exposed to dangerous levels of radiation during a CME. This radiation can damage DNA, increasing the risk of cancer and other health problems. Even passengers and crew on high-altitude flights, particularly those flying over polar routes, could receive elevated doses of radiation during a CME. While these exposures are unlikely to be immediately life-threatening, they could have long-term health consequences. Section 8. Eyes on the sun, early warning systems, and the quest for preparedness. The good news is that we are not entirely defenseless against the threat of CMEs. Scientists constantly monitor the sun using a network of ground-based observatories and space-based telescopes. These eyes on the sun provide valuable data on solar activity, including the formation and trajectory of CMEs. Early warning systems, like those operated by space weather forecasting centers around the world, analyze this data to predict the likelihood and potential impact of CMEs. These forecasts, while not perfect, give us a crucial heads-up, allowing us to take steps to mitigate potential damage. Power grid operators, for example, can use CME forecasts to implement protective measures, such as reducing power loads or strategically disconnecting parts of the grid. Satellite operators can adjust the orientation of their spacecraft to minimize their exposure to radiation and charged particles. Section 9. The future of resilience. Adapting to a world of solar storms. As we become ever more reliant on technology, our vulnerability to space weather, including CMEs, will only grow. It's not a matter of if, but when, we will face another Carrington-level event. The question is, will we be ready? Building a more resilient future requires a multifaceted approach. Investing in robust early warning systems is crucial, as is developing more resilient power grids and satellites that can withstand the onslaught of a CME. But perhaps the most important step is raising public awareness about space weather and its potential impacts. Just as we prepare for hurricanes, earthquakes, and other natural disasters, we must also be prepared for the inevitable storms from the sun. By understanding the risks and taking proactive steps to mitigate them, we can ensure that our technological civilization continues to thrive, even in the face of the sun's occasional tantrums.